Alright guys, so welcome back to a brand new video. So in this video we're going to go ahead and talk about exceptions slash errors. Okay, so they kind of pretty much mean the same thing. I'm going to use you can use these terms interchangeably. In JavaScript they're called errors, but you can also call them exceptions as well. I come from a Java background, so I'm going to refer to them as exceptions. But just know when I say exceptions, it's the same thing as referring to errors in JavaScript. Okay, so pretty much every program is bound to run into errors. When you enter in the wrong password, that's an error, right? That's typically, an invalidation error, right? You entered in the wrong password, or let's say you're trying to read from a file that doesn't exist, right? That would be, some kind of file not exists error, right? And let's say if you try to fetch data from a server, you call some endpoint and the endpoint doesn't respond with anything, or something went wrong on the server side, right? And an error is basically thrown. And when these issues occur, there are often times where, let's say for example, the return value from those operations that throw that error, the next couple of tasks might depend on those, right? And quite often when you have these errors, it just crashes the program and it just terminates, right? So typically when an exception is thrown, right, an exception or error is thrown, it causes the program to terminate and everything is shut down. And so there are some times where we might want to continue on with the program. So even though if something does go wrong, we can still continue on with certain tasks that might not depend on that previous result. Okay? And so again, exceptions, errors, they occur when something goes wrong, such as receiving invalid character input in a form field. And I guess common examples that you may have seen, you may have ran into a couple of things like syntax errors or parsing errors or reference errors, right? The most common example is when we try to reference a variable that hasn't been declared or a function, you'll get something called a reference error, and that's thrown by the JavaScript engine itself. So if you're executing your code on the browser's JavaScript engine will throw these built-in exceptions for you. Right? If you're executing your code on Node, the Node.js engine is going to throw those errors for you. And we're going to take a look at a couple too. All right. Now, so exceptions can also be manually thrown. And what I mean by that is, let's say if you're writing some kind of custom function, and let's say you only want, and let's say that function expects some kind of number, right? Expects only even numbers. And let's say if it gets an odd number, you might want to throw an exception, and that'll tell the user, and it will say, hey, an error occurred, do not pass in odd numbers, okay? However, even though an exception was thrown, right, you want to make sure you're handling those exceptions. That way, even though if the person does pass in an odd number, you want to allow them to continuously enter numbers that are even, right? So the program won't terminate completely. It will just throw an exception. It will interrupt the program for a brief period, and they will just say, hey, don't do this, and then you can continue on with the flow of your program. Okay. All right, so cool. So now we're going to talk about handling exceptions, because again, quite often when programs throw exceptions, it'll just stop and it will just terminate, right? But again, what if we want to continue on with our program and we want to perform a task that is independent from the cause of the exception? Right? Let's say, for example, we're fetching some kind of data on the server, and after we fetch, we just want to add two numbers, right? Those two things are independent. You can add two numbers regardless of the data that is being fetched from the server. Now, unless if that data fetched from a server is dependent, and we're going to use that value to add to some other number or add to some other value, then yes, that would be an issue. Okay? Now, in this case, what we want to do is we want to handle those exceptions, and this is called exception handling. Okay, it's a very, very, very common practice in which we test for potential errors and we handle them accordingly when they do occur. And it allows us to send some kind of feedback if something does go wrong, let's say like an internal server error or a parsing error or something, right? And then, of course, the runtime of our program is not completely terminated, and then they can continue. All right, and in order to handle exceptions, we use try-catch statements. That's what they're called. And we're going to take a look at some try-catch statements right now. So again, I know everything that I've mentioned so far is a lot of information, but I feel like the code will definitely supplement it. So over here, I have a simple program. Okay, I have a simple try-catch statement. Okay, So pretty much it starts with a try keyword, and then we must have this body over here, the curly braces. Okay, it's not like a while loop or an if-else case where if you only have one programming statement inside the body of the try, you can omit the curly braces. You must have those curly braces. Okay, it's very important. All right, and down here, every single try statement must follow a catch statement like this. Okay, and now you'll notice that the catch over here follows with a set of parentheses. Inside this parentheses, it takes in one object, and that's the error object. Okay, and I'll explain a little bit about that in just a sec. And typically inside this catch, right, it's kind of like you're basically catching the error, right? Inside here, you want to do whatever you need to do that's appropriate for when an error occurs. Okay, so now that I've shown you guys the syntax, let's kind of like walk through what's going to happen real quick. Okay, so I guess before I even use try catch, let's actually show you let's actually do a simple example without try catch. So let's go ahead and let's try to log the variable name. Right now we know name actually does not exist. It's not a variable that exists anywhere in this program, anywhere in the scope of this program. Right, nowhere do we have name defined. So if I try to run this program, let me clear. If I try to run this program, you're going to see we're going to get an error, right? This is an error or an exception. You can call it whatever you want. Doesn't really matter. And you're going to see that we get an error, and it says reference error, name is not defined. And that's obviously very true because, one, we're trying to reference a variable that doesn't exist. And that's a reference error. Okay, what if we did something like this? Let's say if we did something like this, right? We should get, I think, a parsing error, or no. We also do get, well, actually this is valid technically. I'm trying to think of something else. Something like this. Oh, that doesn't, hold on. Over here, well, I mean, this is a syntax error, so usually your linter or your IDE will pick it up. But again, there are many different types of errors, right? Let's say if we try to reference a function that doesn't exist, right? So let's say, for example, a console, right? This is a global object. You can see we have all of the functions over here, but let's just try to reference some function that, or some method that might not even exist on console. So let's just say some method that doesn't exist. And obviously this method doesn't exist. I mean, it could, but it doesn't. So if we try to run this program, you're going to see that we also get a type error now. Okay, this is a different type of error, and it says console.SomeMethod doesn't exist is not a function. Okay, so basically this might be a property. Excuse me, this might be a property, but it definitely isn't a function. Okay, now actually the value of this would be undefined because it doesn't really exist. But trying to invoke a property as a function is going to give you something called a type error, right? Just like that. Cool. All right. So now that I've shown you how. Not have shown you, like, you know, what happens when you try to do something like, you know, invalid, right? You get an error. But again, what if I want to do something afterwards, right? So let's say, for example, over here, if I wanted to log hello, right? Notice how console.log, let me save again just to make sure. Okay, cool. So notice how on line 9 we're trying to execute console.SomeMethod that doesn't exist, right? So we try to execute it and we get a type error, but notice how line 10 is not executed, right? If I go on line 8 and let's just say hi, right? So hi is going to be logged. You can see it right over here. But then, so 8 is executed fine, but then on line 9, we get an error on line 9 and the rest of the program doesn't execute. Right? But what if I wanted to do some more things after this, right? What if line 9 was some task that was independent from a bunch of other tasks, right? Because a program can be very large, right? The larger the program is, the more exceptions that you might get and the more other subtasks that are independent that you might want to perform. So what if I wanted to actually, you know, log hello, regardless if this line executes successfully or not? Okay, and this is where we need to apply the practice of exception handling. And for that, we're going to use try catch. Okay, so let's rewrite this. Okay, so remember we have try, that's the keyword, and then we need to follow it with a pair of curly braces. And then we need to make sure, because you can see in Visual Studio Code it has a red line. And so we need to have a catch statement right afterwards. Okay. Now there's one more thing that I will mention, and it's another keyword called finally, but I'll mention that after we go with catch, because you saw in the Visual Studio Code it said finally expected. Okay, but I'll get to that in a moment. Okay, so try and then catch, and then the parameter over here is the error object, and that's the error object that holds the error, that holds the information about what happened. So let's go ahead and do something like this. Let's go ahead and say console.log. Let's try to reference name. Okay. Now, if I go ahead and if I run this program, notice how nothing is being printed. Notice how we're not getting any error. Now, there technically is an error being thrown, but it's just not being logged. The reason why is because now we're actually handling our errors. Okay, so over here on line 2, an error is being thrown. That's the reference error because the variable name or the symbol name doesn't exist. So an error is being thrown, and when we throw an error, you need to catch an error. Okay, this is why you must have either the catch or finally clause right after try. Okay, so let's talk about catch first, and then we'll get into finally. So for catch, right, it's used for catching your error, right? In the try statement, in the try clause, you throw an error, something happened, or an error was thrown inside the try statement, and then you catch that error. Okay, so we catch the error on line 4, and then on line 5 we can go ahead and just say something like an error has occurred, and then we can log that error if we want to. You don't have to, right? But you can if you want, and you can see an error has occurred, name is not defined. And this, although it looks the same as if we didn't have try catch, but that's exactly what the error object is. That's what it contains. It contains reference error. In this case, name is not defined, just like that. Okay, and again, you don't have to log the error as well. Let's say you don't care if an error occurred. You don't even need this. Error parameter. You can actually just omit that like that, and you can run it again. You can just say an error has occurred. Cool. Okay. Awesome. Now, another thing I want to show you is, let's say for example, in this try statement, right? So we know that on line 2 an error did occur. Okay, now remember how I said earlier, what if we want to do something else that might not depend on, if line 2 is successful or not, right? Because obviously right over here, if I go ahead and if I try to do something else, you're going to notice, and well, let's try doing something before. So let's just say hello. Okay, so let's run this. You're going to see it says hello, and then line 3, an error has occurred, right? An error was thrown because of line 3 where we have a reference error. So notice how line 4 and everything else was not executed, because typically, right, when you use try catch, everything that happens in the try clause is dependent on one another, right? And that's one good reason on why you should use try catch. Because let's say, for example, if you are reading data from a file, you want to make sure every single element is being read properly. And if something happens, right, then there's no point on using that data anymore because something went wrong. You may have read an invalid input or something, right? You want to make sure you get all of the values from a file, but you don't have all the values from a file because you read something invalid, right? So you're going to throw the entire exception, and then you're going to catch that down here, because you can't use that data that you had originally read from the file anymore. So everything after the point where the exception was thrown is canceled. Okay, so nothing else will happen over here. So obviously, if I get rid of, if I do define name over here, right? Let's say let name equal Anson. You're gonna see that this is going to work perfectly. Hello, and then Anson, and then we say do something else, right? Every single task succeeded. Okay, so it's very useful, very good, and it's important to know that you should use try catch when you know that you need to do certain tasks that depend on a particular task that might throw an exception. Okay, now let's say, for example, you might have a bunch of other statements that depend on each other, but they might all throw exceptions. So what do? You wrap them all in try catch, and if something does happen, everything else is omitted. And then we catch the exception, and we, send some kind of feedback. We say, hey, something went wrong. Okay. Now let's talk about one other thing too, right? So let's say, for example, let's say we want to try this and it does succeed, right? Or let's say it fails. So if it fails, we're going to catch the error and we're going to do something. There's another statement called finally. Okay. And this clause, right, this body is always going to be executed no matter what. If it succeeds, if it fails, it doesn't matter. It's always going to execute. So over here, if I run this, right, it succeeded. Okay, and notice how it says done. Okay, so in the try clause, we say hello, we print the variable name, do something else, and then inside finally, since there was no error that happened, we log what was inside finally. Okay, let's say if something, let's say if an error did happen, right? We can see an error has occurred, and still finally is also executed. So finally is always going to be executed no matter what. The body of finally will always be executed, regardless if an error occurred or not. So that's something useful to know. So you might want to use finally for certain things, such as cleaning up certain code or resetting variables or something. It's up to you. It depends on what the task is. Okay, and also one thing to note that the scope of each of these blocks. Okay, so let's say variables inside try are not going to exist inside catch. Okay, so and same thing with finally. So just remember that. Cool, because they all have their own block scope. So I just wanted to make sure you guys understood that. Okay, cool. So now that we've talked about handling exceptions, what if we want to manually throw our exceptions? Because right now, the exceptions that we were handling were, just exceptions thrown by the JavaScript engine, right? Now, there are going to be times where you might be using a third-party library. For example, you might be using some kind of library to build a chatbot for, Slack or Discord, or you might be using a library that that you can use to fetch APIs, right? Fetch data from APIs, and those tasks can also fail at some point too. And of course, if the author of the library did a good job at handling their exceptions, they will always be sure to, throw errors when something goes wrong. And then, you'll just have to handle them yourselves. Okay, but oftentimes, regardless, we still need to make sure we're handling our errors, handling our exceptions, no matter what. Okay, but again, if we want to throw our own exceptions, we can do it by using the throws keyword. And I'll show you what I mean in just a sec. So let's go ahead and do this. Let's go ahead and let's see. I'm going to go ahead and create a function, and let's just say check. Let's just say is odd or is even. Okay, so this function is going to take in a number. It's going to take in one parameter, and that parameter is going to be a number. Okay, and what I want to do is I want to check if this number, if this parameter is actually a number, and we can do that by using the type of operator. Okay, so we can say if type of the variable num is equal, because type of will return the value. It will return the data type of the variable or the value in string form. Okay, so we're going to check if type of is equal to number. Actually, we should say not equal to. So that way, if it's not equal to, we're going to throw a new error. So we're going to say throw new error. Okay, now error is an object. Remember, pretty much almost everything in JavaScript are objects except for primitives. Okay, so even error messages are object itself. It's an instance of an error class. Okay, and the constructor is going to take in the message. So this is whatever you want to input. So since we are checking if the number is, we can just say not a number, just like this. Okay, so this is just our handling the exception ourselves. Okay, so let's say if this is false, it is a number. So then we can go ahead and say if num is not, if let's say num mod 2. Remember, if we want to check if a number is even, we can just take the modulus and the modulus of 2 and just check if that's equal to 0. But since we're checking if it's even, or we're going to check if it's not even. And if it's not even, we're going to throw a new error. Not an even number. Okay, and if it is even, we can just do something else. We can go ahead and say return true, like that. Okay, now this is not really ideal because typically if something like this, you typically want to return a Boolean value, but we're only returning one Boolean value. But the rest, I mean, yeah, this works. Okay, cool. All right, so now one thing to note that if you have a function that throws an error, you want to always make sure you're using try catch. Okay, you want to always make sure you're using try catch to handle that function. You always want to make sure you're handling your errors. Okay, always want to make sure, it's very important. So let's go ahead and let's do try catch. And what we're going to do is we're going to go ahead and call is even. Okay, so we're going to go and say let's flag. So this is going to represent if the number is true or false. Or I'm sorry, if it's even or not. And what we're going to do is we're going to go ahead and say is even. We're going to pass in 5. Okay, so this is going to throw an error, and we can log this down here. And you're going to go ahead and see. So let's do node exception.js. Hold on. There we go. Perfect. So you can see that we get the error, not an even number. And it just prints out. This is like the stack trace, basically. So you don't have to worry so much about this. This is like the stack trace and where it like builds up to. So don't worry so much about that. Okay, so let's go ahead and so obviously right now, if we were to try doing other things, it wouldn't work because we throw an error over here. Right? And likewise, let's say if I pass in a string like this, it's going to go ahead and say it's going to go ahead and say not a number right over here. Okay, and let's say if I pass in the string 5, right, it's going to also say not a number. Okay, cool. I mean, obviously you can add more robust checks too, because obviously, you know, let's say we wanted to make it so that it works for the string 5, right? What we would do is we would convert that string we would try to convert that string to an integer, and if it works, right, if it succeeds, that means that it's an actual numeric value but represented in string form. Okay, and I think you can do that using parse int. Yes, you can do that. So let's just say, for example, let me see. So let's see. So what I want to do is I want to make it so that it works if I pass in this string value 5. So what we can do is we can actually, okay, let's do that. Okay, so the parse int function actually, I think, throws an exception itself. Okay, so we can actually test this real quick. So let me just comment this out, and let's just try parse int ansinn. Okay, and it should throw an error, or actually, I don't think it did. I think it actually returns undefined. Or let me see. Well, what actually happens? Okay, it returns nan. Okay, that's fine. So, okay. Cool. And nan stands for not a number. Okay, so, okay, cool. And if it was actually a number, it will just return the actual number itself. Since we pass in a non-numeric value, it's just going to return nan, which stands for not a number. So what we can do is we can go ahead and do this. So inside this is even, we can first say, okay, so it's not a number. Then let's go ahead and check to see if we can convert this number into an actual numeric value. So let's say if we pass in the string 5, let's see if we can convert it. So we're going to go ahead and say if parse int num is equal to nan, okay, we're going to go ahead and say throw new error, passed in invalid string, something like that. I'm just trying to avoid having the same error messages. And since we only have one clause, or since we only have one programming statement that's to be executed conditionally, I can get rid of these curly braces just to save a couple more extra lines of code. Okay, cool. So let's go ahead and try this now. And we should see that we still get... oh, that's because we have over here. Okay, actually, we need to put this up over there. The reason why we're still getting that error is because over here in this if condition, we are first checking to see if it's not a number. Okay, and since it's not a number, we're just going to throw that exception immediately. Okay, so it's better if we check to see if we can convert it first, and if we can't convert it, then actually, yeah, I think actually if we can't convert the number, then I think it should be fine. Actually, sorry, I know I'm thinking like I know I'm kind of like going a little bit off topic, but yeah, this is a pretty cool exercise that I feel like would definitely strengthen your skills. But anyway, so yeah, we're basically trying to parse the number, and if that value is not a number, nan, then we're just going to say pass an invalid string. So I think at this point, we can actually ignore this, because since, let's say for example, if they passed in an invalid string, okay, then this error would be thrown already. So we don't need to worry about checking if it's a number. Okay, so we can get rid of that. Okay. Cool. And since we throw a new error, it will just go back to here. It won't execute the rest of these. Okay. Okay, so let's try this again. And you're gonna see that hold on. I didn't save. There we go. Wait. Oh yeah, okay, so now we're getting not an even number. Okay, we're getting not an even number. So let's say if I pass in quotes 8, so the string literal 8, not the numeric value 8, string literal 8, you're gonna see that we don't get an error. And it's gonna say we can log flag, and that's gonna return true. And you're gonna see it says true, just like that. Cool. So I hope this was a good exercise. I hope this entire course definitely gave you a better understanding of exceptions, and hopefully you guys understand what exceptions are, why they're important to understand, why it's important to handle your exceptions, handle your errors, and understand that programs are always going to run into errors, right? So this is something important to practice very, very often. Okay, so I will see you guys in my next video. Peace.